Are we live? I think we're live. Alright, hey y'all, it's Miss Scott with another genetics video. Yay, genetics! Today we're going to look at incomplete dominance and how that's different than complete dominance and what that means and how to set up Punnett square up for it. Alright, so with incomplete dominance, what you have a situation where neither allele is fully dominant over the other. So we've been talking about complete dominance in the recent days of class where you have one dominant allele and one recessive allele. And if you have a dominant, even if you have the recessive, the dominant is what shows through. With incomplete dominance, that's not the case. In an incomplete dominant situation, if you have an individual that is heterozygous, they have one of each copy of the allele, they produce an intermediate phenotype, like an in-between. And that is how I remember incomplete. Incomplete is in-between or intermediate if you're heterozygous. A classic example of this that you're going to see a bunch of is with flowers. You know, if you take a red flower and you cross it with a white flower, your offspring are pink flowers. So they're this in-between. You could do this with any other color, you know, red and blue, green and something else, I don't know. But you get the picture. In between. So let's take a look-see at some problems that we would need to use the incomplete dominance rule. There we go. Incomplete dominance. Let's see if we can zoom in on that for you. And zoom out a little. Okay, there we go. Alright, so incomplete dominance, keyword, intermediate. When I make any of my Punnett squares, regardless of what kind of inheritance I'm using, I always want to make a key. So here, that's what we're going to do first. We're told in blue flowers, big B are incompletely dominant to red flowers, B prime. Show the offspring of a cross between a purple and a red flower. Okay, so here we have to do a little inferring. The allele B, that codes for this blue phenotype. B prime is going to be red. Now, in most problems that I've seen, that I've come across, they will use one of the letters and then the other allele is just that same letter prime. I have seen examples where teachers, folks will use different letters, like they would use B and R, and that's not necessarily a bad thing. When we talk about codominance, we'll use different letters. As long as you understand that when we're talking about incomplete, if you have one of each kind, you get this in between. It won't really affect it. All right. So let's take a look. Let's set up our Punnett squares. The first thing we do with all our Punnett squares is set up the parent's alleles, parent alleles. So we have one purple flower and one red flower. So purple, because I know my color wheel, I know purple is this in-between between blue and red, which means the purple flower must have one allele for blue and one allele for red, which is B prime in this case. The other flower is red, which means they only have these alleles that code for red. So B prime and B prime as well. Once I do that, then I cross it just like every other Punnett square I've ever done in my entire life. So I will bring this B down and this B prime over to B prime, B prime, B prime, B down, and B prime, B prime. So now I look at my distribution or my ratios that I have, you know, which offspring look like what. These two offspring here in this particular column, here's my phenotypic ratio, I have two that are going to be purple, like this parent, that have one blue allele and one red allele. This, again, go back to my key, B prime is red, all B prime alleles, which means this flower will express only the red phenotype. Same with this offspring, so I have 2 red. Note I don't have any blue offspring because this parent here didn't have any of those blue alleles to start with. So I have a ratio of 0 to 2 to 2, which we could simplify. I have a chance for every 1 purple offspring I get, I should get 1 red offspring. Those are my odds. Alright, what's the probability that these 2 parents will produce a purple? So again, probability, that can be written as a percentage. 2 out of 4, if you get 2 out of 4 questions right on a quiz, you got 50%. So there's a 50% chance that any one of their offspring will be purple. Okay? So let's look at our next example here. In 4 o'clock flowers, red is incompletely dominant to white. Show a cross between a red flower and a white flower. What are the phenotypes? So again, I'm going to make my key red. So R will be red. R prime will be white. I know the red flower must only have these red alleles, so 2 R's. And the white flower must only have these alleles that code for white. So R prime and R prime. So I will mix them. I will cross them. There's R, R prime, R, R prime, R, R prime. And again, just like with Mendelian genetics, whenever you have 2 parents that are homozygous, they have the same alleles, but they're different from one another. So this is homozygous for red, homozygous for white. All of your offspring, 100% of your offspring, are going to be heterozygous. In this case, the phenotype, the in-between between red and white, is going to be pink. And that is how you set up incomplete dominant Punnett squares, and that's how you read them. If you want to get better, if you're looking to improve your ability to do Punnett squares like this, my recommendation is to practice as much as you possibly can. If you go online, which you already are online, because here you are on YouTube, so don't tell me you're not, because you are, clearly. Look up, incomplete dominance practice problems. It's all over the internet. You can find it, test yourself, and you will indeed improve. So have a great day. If you have any questions for me, leave them in the comments, and I'll get back to you ASAP.